In this video, I want to show how to make a visual aid for experiments with a laser beam. With this setup, we will be able to clearly and visually see how the laser beam reflects off mirrors and how its trajectory changes depending on the angle of incidence. As the main element of our stand, we will use a laser pointer. Although this pointer is considered conditionally safe, it is better to use it with protective glasses, as it can emit infrared radiation that is dangerous for the eyes. We will also need small mirrors attached to some base. Under the base, I also placed a small magnet to attach the mirror to a metal pegboard. Also, to make the laser beam clearly visible, we will need a fog generator. I will use a homemade fog generator based on an ultrasonic piezo generator. Such generators are widely used in portable humidifiers or inhalers. I printed the water tank on a 3D printer, having previously created a model in the Fusion 360. I use this program for almost all my DIY projects. It is quite easy to learn, but it has a huge number of useful functions that simplify modeling. You can also get STL files for 3D printing from it. The laser beam is best seen in an environment consisting of small particles. In our case, these are water particles, but you could just as easily use flour. Next, we attach all our devices to the wall and start the experiments. We adjust the sprayer so that the laser beam is as visible as possible. To start, we take one mirror and clearly demonstrate that the angle of incidence equals the angle of reflection. You can add as many mirrors as you like to the experiment. By turning each of them, you can see how the light beam will behave. As you can see, due to the intensity of the mist, the beam is quite visible. I think such a demonstration will capture the attention of even the most bored students. You can also move the light source itself and observe how the angle changes on all the mirrors. You can also add a two-way mirror to the experiment. It can simultaneously transmit light and reflect it. Thus, it splits the beam into two beams. Despite this, the laws of light reflection remain unchanged. You can demonstrate this by rotating both mirrors. With several regular mirrors and a few two-way mirrors, you can create beautiful patterns using light beams. Well, then you can hand the laser stand to the pioneer. Don't forget about eye protection. And that wraps up our demonstration on how to create an engaging STEM experiment focused on the laws of light reflection. I hope this practical setup not only clarifies the core principles of physics, but also inspires students and learners to delve deeper into the fascinating science behind how light behaves. Remember, the best way to learn is by doing. Thanks for watching, and as always, keep exploring.